We sign many different types of contracts throughout our lives. We sign a mortgage to get a loan for a house. When we go to the hospital, we sign a piece of paper that defines how our medical data can be shared between organizations. These pieces of paper, or PDF files, represent our opting into an agreement that will be mediated and enforced by computer interactions. We can't see the code behind those computer interactions, and we can't verify that it is abiding by the contract that we agreed to. Smart contracts allow for programmatic execution of contractual agreements. Code is law, and there is less ambiguity. The most widely used smart contract platform is the Ethereum blockchain, but several large enterprises are creating their own contracts. Should all smart contracts be decentralized, or do enterprise consortium blockchains make sense? It's an open question. In this episode, Marley Gray from Microsoft joins the show to discuss enterprise smart contracts and why you would want to use them and how they can be architected. Marley has worked on banking and financial technology for over a decade, and he makes some strong arguments for why banks will adopt smart contracts and other financial systems too, and other supply chain networks. And the timeline for how that might take place is also discussed. I know that some people are a little tired of the cryptocurrency episodes. We would love it if you filled out our listener survey at softwareengineeringdaily.com/survey so we have some concrete feedback, or you can send me an email, jeff@softwaredaily.com. I would love to hear from you. You can also join our Slack to interact with our community at softwareengineeringdaily.com/Slack. And in the meantime of these cryptocurrency episodes, if you're really tired of them, just check out our back catalog of episodes at softwaredaily.com, or you can download our apps, which have all of our episodes, including our greatest hits list. And the apps will soon have features like offline downloads and bookmarking, so it will be more like a legitimate podcast player. I hope you enjoy this episode. Today's sponsor is Datadog, a cloud-scale monitoring and analytics platform. Datadog integrates with more than 200 technologies, so you can gain deep visibility into every layer of your stack, and any other data that you're interested in tracking as well. For example, you can use Datadog's RESTful API to collect custom metrics from your favorite crypto data sources, and analyze trends in Ethereum prices over time. Start a 14-day free trial, and as a bonus, Datadog will send you a free t-shirt. You can go to softwareengineeringdaily.com/Datadog to get that free t-shirt. And thank you to Datadog for being a continued sponsor. Get that free t-shirt at softwareengineeringdaily.com/Datadog. Marley Gray is the director of the Enterprise Ethereum Alliance and a principal architect at Microsoft. Marley, welcome to Software Engineering Daily.
Thank you.
Before you started working on blockchain technology, you were working on technology strategy for banking and capital markets, financial systems. You're working on these things at Microsoft. What caused you to shift over to focusing on decentralized technology?
Well, it was the introduction of a concept of a smart contract, which really unlocked sort of a lot of other potentials. And the second piece was the introduction of having private blockchains, where we could get over some of the regulatory obstacles that prevented blockchain from being sort of a viable solution to be used in that industry. So that was the thing that really unlocked it. And then that just sort of opened the Pandora's box, if you will, from that point forward.
Then back in 2014, 2015, around the time Ethereum came out, what was Microsoft's perspective on decentralized technology?
We were early sort of embracers of Bitcoin, from accepting it as a payment instrument for our Xbox and marketplace and things like that, just to see what it was going to be like. You know, from a decentralized, we have a long legacy of decentralized technologies around. You can go back to our GRU sort of decentralized sharing of files. And so there's a whole bunch of things in the gaming arena for multi-party games. And then we've experimented a lot with the combination of the cloud with decentralized technologies and what the capabilities there would be. So we've done a lot of things sort of across the board of Microsoft and decentralized technologies. And so I would say there was a healthy understanding and then also a respect of some of the pitfalls that have occurred in the past.
And I think that there is this tremendous wealth of opportunity that's going to arise as we see the blockchain cloud solutions emerge. It definitely feels like it's very early. How has your thinking around the ways that blockchains can interact with a cloud provider, how has that thinking evolved in the last couple of years?
Well, it just keeps refining. So one of the first things I went about was to immediately try to think about what were the limitations of a decentralized sort of smart contract-based system. And it was always around the scale and ability to execute the number of concurrent contracts to be able to get to sort of internet scale, which I immediately knew that we would need to introduce something like separation of concerns to be able to separate the logic execution from the actual ledger itself, but then somehow tie them together cryptographically so you preserve the integrity of the blockchain. And when you look at the historical record, you not only trust its integrity, but you can also build upon the historical truth and just keep going there. So that has evolved. So how would we do that? So the evolution of this is really finding the technology solutions. And at the time, certain things didn't exist. The notion of what we could do from a privacy perspective for running logic in the cloud using something like an enclave. So Intel's SGX chip became very interesting, solved a particular problem for us. And then the whole multi-party aspect of the blockchain was decentralized, but we want to be able to have shared multi-party compute. The other thing we wanted to avoid was to prevent duplication of effort just for the sake of duplication of effort. It tends to slow you down. If we can figure out a way to really increase the performance and the scale by, again, preserving that integrity, improving that integrity. So the evolution of that has been sort of how we do that. What are the frameworks that we do that? And then what's our first sort of go-to-market? We've come a long way, and we hit lots of dead ends and had to back up and go other directions. But that's the thinking is how do we make the cloud and a decentralized network better together, right?
Right.
So how do we let each optimize what they're good at doing and not try to do everything in one place? That's boneyard of failed architectures in the long run when you try to get to scale that we're talking about for public blockchains or even consortium blockchains.
So you've written about this unease that you had early on when you were looking at smart contracts, and the way that smart contract execution on Ethereum works is that when you write a smart contract, and you deploy it to Ethereum, that smart contract gets deployed to every Ethereum full node. And when you execute a smart contract, that execution takes place on every Ethereum full node. And that's a great proof of concept way of having decentralized computational consensus. But it's much less clear that that is the end state of how we do decentralized execution of computer programs, because it's something instinctually feels less efficient about it. And even if you look at the decentralized efforts to make the smart contract execution more efficient, like you look at something like, I think Plasma does this, where they have side chains that are, the computation is not necessarily proceeding on the main Ethereum chain, but it checks in with the Ethereum main chain occasionally. So anyway, you were starting to see this host of different models for pushing side chain computation. You could imagine that the same sort of thing with a cloud provider, with having these trusted consortiums that trust each other doing their own sidechain computation. Maybe they check in with a main chain, maybe not. But there's obviously a variety of ways that this computation could take place. And it doesn't surprise me that there has been some sputters and false starts, because this stuff is really hard.
Yeah, if you look at the way the initial implementation of smart contracts was done, it was done with the assumption that everything had to be completely trustless. So in that manner, running fully deterministic code and having every node execute that contract and to achieve the consensus of the results. So it really, and doing that in serial, so you can't do it in parallel. It basically gives you that consistent state and lets you have this achieved consensus. But that ultimately, that one assumption isn't always the case. And for the most part, in the enterprises, that will never be the case. So if we look at the interest in blockchains and across industries where you have strong regulatory constraints around knowing your customer, so you can't have sort of trustless. You're going to know who the counterparties are in your contracts. And once you start to do that, then you start to say, well, really the only parties that are going to care about the result of this contract are not everyone on the networks going to really care. It's just the parties that are signed up to it and perhaps a regulator. So then how do we prove that to the satisfaction of all those interested parties? And that lets you then say, okay, well then what are the assumptions we can have? A, we would have some sort of backing of strong identity. And then B is we know the public cloud is going to be here, whether it's Azure or AWS or Google. You're going to always have some cheap, elastic computing out there in the cloud that you should be able to reach out, at runtime and spin up a secure execution module to run some logic for a contract on this particular blockchain or blockchains. And then you can start to do all sorts of interesting things when you do that. And that lets you start to do interoperability between chains using a middle tier rather than trying to integrate chains directly node to node, which is, again, if you go back in historical context, integration efforts that are at the data tier are just riddled with disastrous results. It's much more efficient. You have a lot more nimble integration capabilities when you sort of do it in a sort of a brokered fashion with a middle tier component that could talk to each different platform and make reasonable choices and pragmatic sort of decision points that you're not always going to get, and be able to adjust to changes and not be such a brittle integration. So it's when you start to look at these things and you can say these are the assumptions that we can go with. We have lots of design choices that we can make. The simple one was that whole how do we just in time go out and grab some secure container to run some contract based code, and then we can prove that contract code for a series of proofs, and not just one single proof, but a collection of proofs that will satisfy the requirements of the most, well, not the most, but 90% of the market would be satisfied, and that it was done on the up and up, and is far exceeds what they're doing today on pen and paper and fax machines and all sorts of processes that are out there that this could replace.
A few use cases that I consistently hear around the discussions of enterprise consortium blockchains are, one, you've got the question of a loan. So, Marley, you loan me some money, and we want to have that loan codified in a smart contract. And maybe we don't necessarily need the entire blockchain to verify the transactions and the payments and the the payment schedule of that smart contract. Maybe we're fine just leaving it to some set of nodes, or maybe it's my bank and your bank, and they're maintaining consensus with each other through some set of nodes. So there's that kind of use case. There's also the use case of the supply chain where you use smart contracts to verify that, as for example, an apple makes it from an orchard to somebody that's holding that apple in a warehouse to somebody that is selling that apple at a grocery store. That apple, it is the same organic apple that was grown at the orchard, and it was not swapped with an inorganic apple somewhere along the supply chain. You can imagine using these consortium blockchains for the same sort of purpose. Again, you don't necessarily need the entire Ethereum blockchain to agree that apple is still the same organic apple. Maybe you just need all the different players along that supply chain. You need the person who grows the apple, the person who stores the apple for a while, the person who sells the apple, and maybe even the person who buys the apple. You just need this subset of people who are involved to agree on the transactionality. So would you agree that those are both kind of use cases that we could be thinking about from the consortium blockchain level?
Yes, absolutely. I mean, those are sort of like the beginning use cases, and we'll see them get more and more advanced as people start to get a hold of some of this next generation multi-party compute in a distributed sort of application model. We'll start to see these use cases sort of get more and more complex, and whole new businesses will be created in this sort of ecosystem. But yeah, those are some of the ones that most people can sort of reason and understand to begin with.
Right. And so just to play the devil's advocate here, because I think that these enterprise consortium blockchains make sense, but just to play the devil's advocate for people who I know are skeptical of the enterprise blockchain stuff, why would you need a blockchain for this? Why wouldn't you just have a database with shared permissions? Or even if you wanted to get crazier, you could have a virtual machine that all the different players involved have access to a complete log of the virtual machine. Maybe the virtual machine has a verified open source operating system, so everybody can agree on the operating system, everybody can agree on the programs that are running in it, and then maybe it has a very detailed log of the computations that take place in that computer. Why do you need a blockchain to fulfill those kinds of things?
Yeah, so I usually try to put it in a simple form and say, let's assume that all history of mankind is recorded in one place. And we all go to that one place, and it's one physical location, say a library, central library of the world or humanity or wherever. And actions happen, events happen, they get recorded there. And then maybe some atrocity happened, and somebody wanted to go erase that from history. And do that in a way, even though all the data from that point forward is, cryptographically built upon those things, it becomes a very simple exercise of going into that one source, manipulating the data and erasing some data, and then rebuilding the cryptographic proof tree from that point forward all the way to the front. There's no one to dispute that. There's not another copy of that data that can dispute that historical change. Somebody has gone back and changed history to that effect. So when a blockchain essentially says, well, we're not going to have just one library, we're going to have thousands of libraries. And to be able to do that, and the libraries are constantly in sync, and they have a sync window of, say, make it an hour, then for someone to be able to erase history, they would have to be able to perform that function and that step in a coordinated way within that time window of all the copies at the same time to pull that off. Which that in itself is just one sort of scenario where, having, a blockchain or a distributed set of distributed truth is powerful, and it creates this foundation for trust, and even trustless environments that we get there. And that's probably the first step from just a recording of the ledger and keeping a ledger distributed, and what the benefits of that are. And then you can throw in the whole disaster recovery, your data, the place physically where the database was stored was blown up or something, and its backup was in the next region, which was a nuclear attack or something. You lost your data. Whereas if it's fully distributed, you'd probably have copies around the world and maybe on the space station. Who knows? So that's one scenario.
We are running an experiment to find out if Software Engineering Daily listeners are above average engineers. At triplebyte.com/sedaily, you can take a quiz to help us gather data. I took the quiz, and it covered a wide range of topics: general programming ability, a little security, a little system design. It was a nice short test to measure how my practical engineering skills have changed since I started this podcast. I will admit, although I've gotten better at talking about software engineering, I have definitely gotten worse at actually writing code and doing software engineering myself. But if you want to check out that quiz yourself and help us gather data, You can take that quiz at triplebyte.com/sedaily. And in a few weeks, we're going to take a look at the results and we're going to find out if SE Daily listeners are above average. And if you're looking for a job, TripleByte is a great place to start your search, fast-tracking you at hundreds of top tech companies. TripleByte takes engineers seriously and does not waste their time. I recommend checking it out at triplebyte.com/sedaily. That's triplebyte.com/sedaily. Thank you, TripleByte, for being a sponsor. So if I think about that explanation, so I think what I hear you saying is we could do this. We could have these shared consortium blockchains built out of our classical databases and blob storage systems and logging systems and operating systems. We could do that. I think what has happened is Bitcoin came out, Ethereum came out, and people started thinking deeply about these ideas of trust. And Bitcoin and Ethereum illustrated the extremes of trustless environments. Although it's still pseudonymous, so maybe it's not completely trustless. It's still centralized in terms of the proof of work, miners being centralized, but it's pretty trustless, decentralized system, at least just as a thought exercise. And then what happened was people started thinking about, hey, why haven't we been thinking about this way that, maybe subsets of the entire world can share a source of truth? Like, maybe you want to have banks to have a central source of truth that just those, 5 or 6 banks are referring to, or, maybe you just want these different people in the supply chain to be able to agree on this space of data and this history of transactions. And again, it's not necessarily that these shared trust systems that are not totally non-trusted, it could not have existed before blockchain and proof of work. It's more that the zeitgeist, like what people were thinking about, got changed by Ethereum and Bitcoin. And so, a company like Microsoft started thinking, wow, this is pretty widely applicable. How can we build that? And it doesn't even, you don't even really need like a proof of work system. It's just more like this is an insight that we could apply to different business scenarios that we're working with. Am I articulating it correctly?
Yeah. And the common fallacy, people, they approach this and they think of, well, trust is Boolean, but it's not. Trust is not a true or false. There are ranges of trust, and I usually have people and say, okay, let's assume that you just got your brand new Porsche, you drove it off the lot, and you have 2 people coming up to you and asking to borrow your keys. They have to go somewhere in an emergency, right? If it's your spouse or your brother, you're more apt to give them their keys. If it's a total stranger, you're not going to give them the keys, right? You don't, even though, or maybe it's somebody that you know from work, but just in passing. So you would say hey to them, but you're not going to give them your keys to your brand new, treasured possession, because even though you might say you trust them, but you don't trust them like that. So yeah, it's a sliding scale, and then so that's one of the things that people walk into with some baggage when they think about blockchain. Is they say, hey, it's either trustless or it's fully trusted, and that's not, the word trust is analog. And then the second piece is they entangle the truth and the resolution of the truth together. And that's where, when I started, I was on to pry those two apart and say the blockchain is where we persist the truth, we store historical truth and current state of the truth, but we resolve it somewhere else. And that resolution of the truth we can optimize for whatever the use case is. And the only thing that we have to do there is just have the proofs of where we're resolving the truth and persist those with the truth, along with the truth, so that we can have the ledger to see the truth and then have the proofs of how it was resolved. And that really gives us this sort of elegant sort of approach to sort of building systems on these two principles.
So maybe we could just talk about the enterprise architecture of a smart contract. So we've done several shows about how smart contracts work on the Ethereum blockchain. How would you contrast that with how smart contracts might work within an enterprise consortium, a group of enterprises that want to operate in a way where they don't necessarily trust each other, so they just want to have some way to have a system of trust between those enterprises.
Right. The way we've architected this we're calling them enterprise smart contracts, and it used to be called cryptlets, and it's still called cryptlets from a developer standpoint. But essentially, you still use the ledger to define. Every contract has a couple of properties. One of them is essentially you have some sort of business schema. So how do you define what it is your contract's keeping up with? Usually it's the terms, who the parties are. If it's a loan, it's how much are you borrowing? What's the interest rate? What's the payment schedule? When is the payment due? What happens if the payment's late? And you sort of record all of those things, and then people, agree on it and they sign, and that thing should, essentially execute. That largely stays the same, right? You're still going to record essentially the schema and then all the transactions as that thing becomes bound. So each of the payments and the recording of those payments are then recorded in that smart contract. The difference is the logic, once it's sort of bound and executing, can then be pulled off chain, and there will be a cryptographic set of trust. So like on Ethereum, you can use what we call function modifiers to essentially guarantee that only certain parties can alter the state. We assign that to some code that's running that the parties have agreed to. So we can then have that logic written in a language, Java, .NET, whatever. Just figure some runtime that you want to be able to support. The counterparties can, if it's a brand new contract, then you would have some vetting to go through. But let's assume it's one that's been tried and true, has a great reputation. It's been thoroughly threat modeled, all that good stuff. And we can just pick it out of a marketplace, right? It's a loan cryptlet that we can then say, hey, this guy is going to control our loan, and we agree on that. And it's going to generate and execute and the results of this loan, and it will persist not only the result of its calculations to record the truth of the payments and, if there was a penalty and, how was that determined, but also the proofs that go along with it. So that essentially lets us pull that logic out and run it, set of code that's running in the sort of a shared model. And then the code runs once, essentially, and we can run it in a shared environment like the cloud. And in this case, if you don't do it like that, usually what will happen is when it's running in duplicate, each of us is responsible for bearing 100% of the cost of a contract, but only deriving maybe 50% of the value. Whereas if we run it in a shared, execute it in a shared environment, then we can split the cost and equal to the amount of value that we receive, or I can also use the cost of computing that result as an incentive. So if I'm the seller of a contract and you're the buyer, as an incentive, I can tell you I'm picking up your fees. Does that make sense?
Yeah, it does make sense. And you mentioned along that definition the term cryptlet. Can you define what a cryptlet is?
Right. Yeah. So cryptlet is the term that I came up with way back in 2015. It is just essentially a play on words. So the servlet it's a middleware component. That's a piece of code that runs, understands understands the cryptographic primitives that blockchains do, but also has the ability to do cryptographic operations without the developer having to know that that's what they're doing. So it's essentially you write your code in whatever language that you want to and focus on the business logic of those different things and be able to then have that result that you've computed in your code automatically be proven cryptographically. So digital signatures created. You could do things like encryption. You could do all sorts of things and not have to write the code. So the cryptlet is sort of this platform that you write your code in that wraps all those capabilities and then also abstracts your business logic away from the actual blockchain itself. So it will work across any type of blockchain. Very similar to most middleware. If you go back and look at sort of like J2EE and database abstraction between sort of an Oracle relational database and a SQL Server and Informix, and that really freed up and unlocked a lot of solutions to be built in a cross-platform and cross-database way. We're talking about the same thing for blockchain. So you can build a solution or a enterprise smart contract that will work against, Ethereum, Quorum, or Hyperledger Fabric, or Corda, or whatever, and it becomes sort of this portable contract that you could use. So that's what Cryptlet is. It runs in the Cryptlet framework in Azure, and it's a sort of a cloud. This is that shared sort of execution space that a Cryptlet runs in.
So would you say that a Cryptlet is essentially, it is a smart contract that adheres to the components, the definition of a smart contract that you defined in this white paper that you wrote? So you've got some different components. You've got the schema, you've got the logic, you've got the counterparties, you've got external sources, and you've got the ledger, and then the contract binding that brings it all together. And the Cryptlet is just the notion of a smart contract in a enterprise blockchain. Is that right?
Yes. The accurate description is, it's contracts. And if you've ever taken out a contract, which everyone has, everything's a contract essentially. But I usually, the contracts are templates, and no one really writes contracts from scratch any longer. You're pulling clauses and things together and composing them of these components, and then it becomes an instance of a contract when the counterparties have signed to it, and then just executes. And we're talking about the same thing here. It's just we're decomposing those actors together and let them be composed in this framework. And then the Cryptlet is just the logic portion of that. Now, the blockchain, you can tell it to, if the framework's been configured to work across 3 different blockchains, when you're instantiating an instance of it, you tell it which blockchain you want to have it home to, and it essentially binds to that blockchain for its primary state. And then you can start to do some very interesting things by having other Cryptlets that are using those other Cryptlets that are pointing at different blockchains to create sort of smart contracts that work simultaneously across different blockchains. For example, moving or trading assets that are recorded on one blockchain and transferring them on a completely different blockchain on a whole other platform. You could execute a transaction like that. And in fact, we share that in one of our examples and sample code for the Cryptlets framework today.
So I'm wondering to what degree enterprises have started to adopt this stuff, or if they're just starting to tinker with it, and if there are some sort of bottlenecks that they are waiting to be surmounted before they start coming into the space. Like, what is the current state of enterprise adoption of these kinds of blockchains?
Well, the investment's pretty intensive from a use case. We've gone from sort of an evolution. Early on, everyone was doing these hackathons across companies and trying to figure out what blockchain they were going to use, right? And they would stand up, different blockchains, and they would compare them against each other, and then would deem one the winner, and then they would go forward, which turns out to be completely the wrong way to go about it, because they didn't know what they were going to build on top of it. So you have no idea, based on the requirements that you selected said blockchain, of were they the right things that you were indexing for. And if it turns out you were wrong, you just spent a lot of time. So there's a couple of things that we've done to make that easier. So in Azure, one of the first things we did was try to make a blockchain that's just ridiculously easy to stand up. It was very difficult to stand up a private blockchain before we did that. Now you can do it in minutes and stand up a fairly sophisticated, 100-node geographically distributed blockchain for you to model things after, and do it very quickly and cheaply. So that makes it really easy. Then it sort of, okay, well, let's figure out what we want to do first. So that's probably the first thing, was to get people to stop trying to focus solely on what's the right blockchain, but figure out what is the type of application. What does it mean to be a multi-party application? And it turns out that's a difficult thing for people to get their head around. And that we see that, and there's sort of a fortunate thing I say is it's taking people a while to figure that out, because we're also taking a while for us to build the platform that is truly multi-party, that works across multiple distributed ledgers. That technology we think is keeping pace with where customers are. So our customers are prototyping, and this we have a private early adopter program going on right now, and that's in a certain degree. So that obstacle has become beneficial for us as platform providers to be able to at least keep up with our customers are thinking. And that's been the big shift. It's a total mind shift, the way you think about things. And early on, there were a lot of mistakes, and people building applications on blockchains that had no business being on blockchains, right? A centralized sort of database is a way better type of solution.
Sorry, I didn't understand it super well, but is there a technical bottleneck to them adopting it, or is it just a lack of understanding, or
Yeah,
they're gun shy?
there's a couple of them. Get back to the technical bottlenecks. First is that there's very few people that have experience. Let's take Ethereum, like writing Solidity, right? So there's not a lot of people out there, and there's very few people that can say they've written production code for Solidity. And the definition of production is different for different things, right? So in the enterprise, the production word is a lot different than it would be for, say, a public Ethereum smart contract. So, but there are slews and armies of people that have built production systems in Java and C# and other languages. And there's an army of, patterns and practices and tools, and it's all there. The ecosystem is there. And so the obstacle people go in, they try to do Solidity, and they're like, where are the tools? How do I debug this thing? It's hard because the tools are not there. The documentation's, not that easy to get a hold of. So it is, that in itself is a very large obstacle. Is not only are there not enough skills out there, but the tools are not there for people to really scale this up. So I think this approach that we're building here is addressing that piece. And then the other technical obstacle is sort of that. What the blockchains also have to catch up from a performance perspective, solve problems like privacy as well, and then permissioning and things like that. Those are being worked on as well.
Software Engineering Daily is brought to you by Consensus. Do you think blockchain technology is only used for cryptocurrency? Think again. Consensus develops tools and infrastructure to enable a decentralized future built on Ethereum, the most advanced blockchain development platform. Consensus has hundreds of Web3 developers that are building decentralized applications, focusing on world-changing ideas like creating a system for self-sovereign identity, managing supply chains, developing a more efficient electricity provider, and much more. So, listeners, why continue to build the internet of today when you can build the internet of the future on the blockchain? Consensus is actively hiring talented software developers to help build the decentralized web. Learn more about Consensus projects and open source jobs at consensus.net/sedaily. That's CONSENSYS.net/sedaily. Consensus.net/sedaily. Thanks again, Consensus. So if I understood you correctly, there's a couple things that you're working on to improve the state of adoption and the difficulty of enterprises getting started with this stuff. One, you're building out tooling, so better ways to write, prototype, test, and eventually deploy enterprise smart contracts. That's one part of it. And then the other part of it is actually working on the runtime, the execution environment of these smart contracts. So you've got both of those fronts that you need to make some progress on before you see, for example, Goldman Sachs deploying a futures contract to an enterprise blockchain.
Yeah, but that work is happening now. Both the customers building out what would a futures contract look like on this type of enterprise blockchain, and then they're already, what our customers are seeing is, and what they're saying in this market is, they can't wait for the technology to be fully baked before they try to understand what the new business model is, and that's the fear that everyone has. And when the enterprises look at this and they see this disruptive technology, it's not like it really is going to change business at the DNA level. So they can't wait for this to all be figured out. They have to be in there figuring out the business model, because if they don't, they're going to end up like Blockbuster, and they don't want to do that. So yeah, that we are approaching it that way, and we're also the ledgers themselves. We're helping not directly, sort of indirectly address sort of the enterprise capabilities that blockchains and the characteristics that they could have, and trying to do some heavy lifting there as well to help that overall community.
It must be frightening and at the same time exciting, because I'm trying to report on all this stuff, and it feels to me, like, unless you're like a core developer and you're really at the forefront and you have an understanding of all the research at a very fundamental level, everybody else is sort of fumbling around in the dark trying to understand exactly what's happening and how, on what time scale we are. And because I think most people who spend just a little bit of time in this space understand that things are happening and this is going to have real impact on the way that we do business, but many fewer people truly understand the trajectory. It's more like just this this very misty, landscape that we can barely see 6 months ahead, beyond the 6 month ahead of us time horizon as to how this space is going to evolve and how it's going to impact things. I imagine it can be both exciting and a little bit disconcerting.
Oh yeah, it is. And there's a lot of that fumbling around. But it really has been like that for most technologies. The big driver here that I'll say, being in this industry for so long, and just technology in general, from a technologist standpoint, was most technologists in IT departments around the world missed this completely. But it was the line of business executives, the business people that saw this, and they are the ones that are driving this. And they just so happen to be the ones that write checks, and they have the budgets. And a lot of these enterprises, their IT department is a cost center rather than a revenue generator. And now you have the revenue generators throwing money at this thing saying, we got to figure this stuff out now, because if we get it wrong, we could go away. We might be out of business. Or so we have the whole fear and greed on that side really driving this. So that's why IT feels like, gosh, I'm running so fast and it's very foggy, and I don't know if I'm about to drive off a cliff or hit a pylon, or if I'm going in the right direction even. So yeah, totally like that. But the good news is that it goes forward, that window of how much further you can see in the fog, the distance is getting further. So we're starting to shed we're getting out of the phase where everyone and their brother is writing their own blockchain. We're sort of settling on a couple of those. And that will continue, and you'll start to see further and further ahead, and can make more and more informed decisions as you go forward from a technology implementation standpoint.
So talking specifically about the process by which people write smart contracts and test Ethereum applications on Azure, for example. So what's the workflow like for developers who are building smart contracts today, and what specifically are some of those problems with the developer experience?
Well, yeah, the first thing you have to stand up a network. So that's a trivial exercise. You can deploy a blockchain network in a few minutes. And then the second thing is okay, well, how do I even write a smart contract? And then how do I deploy it to the blockchain? And once it's deployed, how do I interact with it? And then you go out and look, and there's 5 different answers for that. So if you're a .NET developer, you would go out and find a library like Ethereum, which is a great client for Ethereum networks. It makes it, for any .NET developer, pretty simple to take existing Solidity code and create a C# client or a VB client that knows how to create a contract and then can execute transactions against it pretty easily. You could do the same thing in JavaScript with the Web3.js, and then there's Block.io's got a Java implementation. So there's a bunch of different ways for doing that, but you have to sort of say, okay, who's the developer and how do they get started? So that's probably the thing we would recommend. Now, some developers go in and say, I want to do everything in Ethereum. I'm going to write my Solidity code, and I'm going to write my own client, and I'm going to do these different things. And it becomes very difficult. Key management, where are you keeping your keys, and those types of things. It's kind of cumbersome. So you have this whole infrastructure stand up, and then you have to figure out what are the libraries available for me to build this. And let me go find some samples. The good news is there's lots of samples out there, and you can get everything from samples for .NET to Java to Node or whatever platform you're going to. So that's the second one. But then really the thing that you have to do is stand up sort of something demonstrable that has a user interface that that a business person can understand. That second piece becomes very difficult as well, because most of those technologies are built to be single party, where it's a single organizational website, right? It's not a multi-party sort of experience. So it becomes a very difficult challenge. So that workflow becomes difficult as you crawl up the stack because there's less and less sort of samples to look at for how do you do that. So that's one of the areas where we're looking at and where we're investing is to try to fill that sort of void that occurs as you step up and say, okay, I got the basics. I can create a smart contract. I can send transactions to it. I have a great command line interface. Great. Now what do I do with it? That workflow we're working on right now.
So if I think more concretely about a use case, let's say I am a Goldman Sachs type of industry and I want to offer a futures contract that people can transact with. So in this model, I would, first of all, I'm spinning up my own blockchain. And so it's, I'm creating a consortium blockchain, and then I guess other people would opt into that consortium somehow, or help me understand, if I'm Goldman Sachs and I want to make my own blockchain, why would I do that? And what would be the process of onboarding other people who would opt into that blockchain and then eventually setting up something like a futures contract in smart contract form?
Right. So you first have to seed a network. So you can say, let's use Ethereum. And so if I'm that customer, I would then say, I need to seed that. What does that mean? I'm going to create a couple of nodes. I can do that in Azure if I wanted to. And I would create essentially the first slice of the consortium pie. And then if I found some willing participant, then I would invite them to join my consortium. Meaning what they would do is then they would spin up some nodes and join that network. That means that my nodes and their nodes are talking on the same network. So transactions are flowing back and forth. And then we do that for each subsequent party. And that lets us build the consortium network. Now, those nodes can be anywhere. They can be in Azure. We make it easy where you can just create the first seed and then invite others, and they can go on Azure and they can say, I want to join this one. But in reality, what people are going to do is they'll have their nodes in their own data center or some other cloud provider and stitching those together. But essentially, that's the first step is you got to build a network, but you don't have to wait to build the futures contract until that network's built. You can go ahead and build it on your own private, and then you can then move it to whatever blockchain. And once it gets established, you could do those two things in parallel. And that's what we're seeing now is people are starting to build apps before the consortium network's even finished and starting to build those solutions and doing them in parallel again, because the line of business is really pushing the gas here to get something done.
And what is the process by which, so if that futures contract gets created, how does it get deployed? Does it get deployed I guess it gets deployed to each of those nodes, like it gets deployed to my nodes and your nodes. And if I'm Goldman Sachs, I create the futures contract, and you're somebody else who wants to use that smart contract, you spin up your nodes to join my blockchain, and then we're both running the same smart contract. And I guess we replicate our transactions just like the Ethereum full blockchain would. That's the system, basically?
Yeah, so the smart contract itself is, again, an instance until you've created essentially called the constructor on it, and it would deploy. And all you have to do is send it to one node, and it will create, and that instance of the smart contract then replicates to all the other nodes. So the state of that contract with a fixed address is there, and then I can tell somebody else that wants to be a participant in my contract what the address of that is, and they can look at the terms and they can sign on to it. And then once it becomes binding, we just look at that one address, and we know it's of this type contract, so we know what the schema is, and then we just execute our logic. And that's where you say, do I execute the logic in the Solidity code on the smart contract on the chain, or do I want to run that off in a cryptlet? And what are my performance characteristics? In this case, it's probably going to be something they want to have high performance. So we can then say, okay, we're going to run this in a cryptlet, and they'll go, well, geez, where do we want to run it? Why don't we need a Switzerland, in this case, Azure can be Switzerland, and we're going to agree to run our cryptlet in Azure. And it will write the results to this address, and we can all see the results and see the proofs of how that contract executed from this code that we're sharing the cost for in Azure. And so that's the sort of workflow. Now you don't obviously have to do that. You can write all the code in Solidity, and then you'll see the same thing. It's just your logic will run on every single node on the network, and it limits some of your privacy because we do it in cryptlets. We could encrypt the payload before it's written to the blockchain, all sorts of things that you have a lot of advantages in the cryptlet sort of architecture.
So I want to bring this point home because I know we're near the end of our time, but I think this is what's really important for people to kind of understand about this. And you can tell me if I'm wrong, but it seems like, again, you could have built futures contracts on internet infrastructure before. I mean, people have done that. But in the past, I mean, I'm not an expert in financial services implementations, but my mental image of it is that it is not easy to understand the infrastructure. It's kind of kludgy. The integrations are really troublesome and they take a long time to do. And this architecture of we each have some nodes and we replicate our contracts across those nodes, and then we've got a programming language that defines how our transactions are going to proceed. It's just a better programming model than the past cruft that we've built up in the electronic financial system. Is that accurate?
Yeah, it is. The other way, the previous way we did it, we built it with settlement houses. So if you look at the DTCC, and they settle derivatives and over-the-counter derivatives, they're actually a third party, but each of the banks, the big brokerage houses, they spun it up and they created a middleman, and which creates a long settlement time. And there's this, if you look at the equities market, it takes 3 days to settle the trade. And if you actually want to have the assets that you sold it for liquid, it takes another 2 days for it to be deposited in your checking account before you can do anything with it. That 5-day sort of latency is all because we're settling on a centralized database that then has to be reconciled with each broker's ledger. And so we have duplicated ledgers across the brokers that were involved in the trade in this one central clearinghouse. And the overhead comes in the fact that we have to then validate the ledger across each one of those. So that takes time. When we're all settling to one single ledger, we can settle in near real time, which then removes that sort of friction and cost and inefficiency in the network itself.
Okay, Marley. Well, I know we're at the end of our time, but I feel like I understand this space a lot better thanks to this conversation. So I appreciate you coming on the show.
Sure. Great to be here. Thank you.
GoCD is a continuous delivery tool created by ThoughtWorks. It's open source and free to use, and GoCD has all the features you need for continuous delivery. Model your deployment pipelines without installing any plugins. Use the value stream map to visualize your end-to-end workflow. And if you use Kubernetes, GoCD is a natural fit to add continuous delivery to your project. With GoCD running on Kubernetes, you define your build workflow and let GoCD provision and scale your infrastructure on the fly. GoCD agents use Kubernetes to scale as needed. Check out gocd.org/sedaily and learn about how you can get started. GoCD was built with the learnings of the ThoughtWorks engineering team, who have talked about building the product in previous episodes of Software Engineering Daily, and it's great to see the continued progress on GoCD with the new Kubernetes integrations. You can check it out for yourself at gocd.org/sedaily, and thank you so much to ThoughtWorks for being a longtime sponsor of Software Engineering Daily. We're proud to have ThoughtWorks and GoCD as sponsors of the show.
Wow!